Alright, in this video we are going to continue looking at rational expressions, but this time we're subtracting them. I like in the textbook how they separate things out. Like we did a section on finding lowest common multiple, and then we did adding rational expressions, and this time we're going to be doing subtracting. Very similar to adding, with just one little thing that you have to worry about with the subtraction ones. So, just as a quick review, if I'm adding rational expressions, I need to find the lowest common multiple. So, but for the lowest common multiple between x plus 3 and x minus 2, notice if they're binomials like that, you have to treat them as one thing. So you can't treat it as an x and a 2, it's one whole thing. So if this is one term and that's the second one, the lowest common multiple for both of those will be x plus 3 times x minus 2. So I would take each one of those, the x plus 3, and multiply it by x minus 2. And then on the top, if I do this to the bottom, I also must multiply that, plus, and then do the same thing here. This one has to have an x plus 3 and an x minus 2, because that's the LCM. But it already has an x minus 2, so I must have multiplied this on the bottom, so I also need to multiply it on the top. Okay, and then we said write that under one denominator, so I'll have my two brackets on the bottom, and then I'll use the distributive property on both of those, and then collect like terms. So that was just a quick review of what we did with adding. With subtracting, we do the same thing. Make sure they have the same denominators, then subtract the numerators. And like always, keep the denominator the same. However, if when you're subtracting the numerators, you need to be aware of this dirty, rotten, filthy, stinking negative again. So I'll have something minus over here, something over something. This thing right here can be a dirty, rotten, filthy, stinking negative. So we have to be careful with that. And we'll do lots of examples to show you. So here's one. I'm subtracting. These are just fractions. The denominators are the same. So I keep the same denominator, subtract the numerators. Not bad. If there's letters involved, as long as they're the same, keep the same denominator. Notice it's not 2y or y squared. The denominators are the same, so keep that denominator and then deal with the top. Okay, so let's try some more questions. Here's one. Is the denominator the same? Yes, it is. So I'm going to write this whole top thing over top of just one denominator. So I keep it the same. Now watch what I do to help me with this with the numerators. I'm going to take the first numerator and put it in brackets, and I'll take the second numerator and put it in brackets, and then the sign that's right here goes in between them. It might have been a good idea to do with subtraction as well, or with addition as well, but when you're adding, you can just drop the brackets and then add. But when you're subtracting, this subtraction in front of a bracket means I have to distribute it to both. That's why it's a dirty, rotten, filthy, stinking negative. So I'll drop the bracket on the first one, and then this will become a minus 2x and a plus 5 all over x plus 4. And then I'll collect like terms. X take away 2x would be negative 1x, and negative 3 plus 5 would be a positive 2, all over x plus 4. If you wanted to write that as negative x plus 2 over x plus 4, that's fine too. Okay, dirty, rotten, filthy, stinking negative. Careful with that one. Let's try maybe another one. I'm just going to do 5 or 6 questions for you. Same denominator, perfect. I'll write it over one denominator. Might need a longer line. And then the top things I'll put in brackets. 2 squared plus 3x minus 7. From that, I have to take away x squared plus x minus 8. Now, if you can, without making a mistake, apply this negative to each thing inside there in this step, feel free to do that. But if you're starting to make dirty, rotten, filthy, stinking negative mistakes, then slow down and put this step in. So this would be 2x squared plus 3x minus 7 minus x squared minus x plus 8 all over my same denominator. And then I'll collect like terms. 2x squared minus x squared is x squared. 3x minus x would be a positive 2x. Minus 7 plus 8 is a positive 1. Okay, all over 2x plus 1. It's not a bad idea to take this one here and factor it, just to see if you can simplify any more. So this one would be x plus 1 times x plus 1. Two numbers that multiply to 1 and add to 2, 1 and 1, all over 2x plus 1. Now, if the whole thing on the bottom was identical to one of the things up top here, I could cancel them. In this case, this has a 2 there, so they're not identical. This would be my correct answer. If you stopped at this point there, I'd be happy with that as well. Okay, let's try another one. Denominators aren't the same. So I've got 3x and 5x. Well, 3x is 3 times 5. 5x, 3x is 3 times x. 5x is 5 times x. So my LCM has to have a 3 in it, has to have an x in it, has to have a 5 in it, has to, I already got one of those. So this would be my LCM, and I'd multiply the two to make 15x. So this term here, x minus 2 over 3x, to get 15x, I'm going to need to take and multiply this by a 5. But if I multiply the bottom by 5, I'm going to have to take that whole top thing and times it by 5. Similarly, over on this side, I've got minus 2x minus 1 already over 5x, but I need to get 15x to be my common denominator. And so I need to multiply this by 3 and this by 3. Now here's where it gets fun. On the top, this first one, well, yeah, let's FOIL that through. So that would be 5x minus 10 all over 15x minus, let's do the same thing here, this would be 15x, but let's multiply that 3 through, so it would be 6x minus 3. Now we'll do the exact same thing that I did on the other page. Same denominator, so I'll write it all over 1, and I'll have 5x minus 10 minus 6x minus 3. Are you seeing where trouble's going to happen? Right there, eh? So this will be 5x minus 10, I'll drop brackets, minus 6x plus 3 over 15x. Collect like terms, 5x take away 6x is negative x. Negative 10 plus 3 is negative 7, all over 15x. And that would be my answer for this question. Okay, so there's another one. Okay, here's a good question. The denominators look a little bit bigger this time. Now, they look like each of them can be factored, right? So let's factor this first one. And this would be x, two things that multiply to 56, add to 15, probably 8 and 7, x plus 7, minus 6 over two things that multiply to 42, add to 13. That's got to be 6 and 7. So now that I've factored them, I can determine what my lowest common multiple is. So I need an x plus 8. I need an x plus 7. And I need an x plus 6. I already have an x plus 7. There's my LCM. So to this one, and I'm just going to do it right here, I need to multiply the bottom by an x plus 6 to get this LCM. But if I do the bottom, I also have to multiply the top. Same thing over here. Which one doesn't this one have? The x plus 8. So I need to multiply this one by x plus 8 and this one by x plus 8. So I can write them all over the same denominator. X plus 8, x plus 7, x plus 6. And then this one I'll distribute through, so it'll be x squared plus 6x minus, now how would I do that? I guess I could treat this as a minus 6, or I could put all this in brackets, so it'd be 6x plus 48. Notice I still have that dirty, rotten, filthy, stinking negative there, so you have to be careful. So this would be x squared plus 6x minus 6x plus, oh no, not plus, minus 48. Pretty easy to mess up on that dirty, rotten, filthy, stinking negative. All over x plus 8, x plus 7, x plus 6. Then, collect like terms, so I'll have x squared, 6x take away 6x is 0, minus 48, all over x plus 8, x plus 7, x plus 6. And there, I'm done. Okay, getting the hang of it. Let's try maybe 2 more. Ooh, this is an interesting one. Notice that these are similar, but they're backwards. So I can make a swap as long as whatever I do on the bottom, I do on the top. So if this one is 2 minus x and I want it to be flipped, I can change that to x minus 2 as long as I flip this one. So 3 minus x. Okay? Now, I'll do my same thing. Now I've got a common denominator. So I can write an x minus 2 on the bottom. The top will be 3x minus 3 minus x. Notice how when I put them together, I put these in brackets. And that'll help me with that dirty, rotten, filthy, stinking egg. Let's drop the brackets. So 3x minus 3 plus x. You see how we distribute that through? All over x minus 2. And finishing off, 3x plus x would be 4x. Take away 3 on the numerator over x minus 2 on the denominator. Okay, now that's another good one. Just a nice little trick there that you can use. Okay, lastly, let's try one with another one of those tricks. I see x squared minus 9, 9 minus x squared, it's backwards. So let's swap that. So I have x plus 2 over x squared minus 9 minus, okay, we're swapping that. So it's going to be x squared minus 9. And what I have to do now is swap this one. If it's only one term, all I would do is change the sign of that term. But if it's a binomial, I simply swap it. Swap on the bottom, swap on the top. Plus, this one's already x squared minus 9. Oops, I didn't need a bracket. Over negative 8 minus x on the top. I have the same denominator now, so I can write it over one denominator and then just write all that stuff on the top, remembering to put brackets between each one. Minus 7 minus x plus negative 8 minus x. Carry my little line there. Okay, let's drop the brackets. So this would be x plus 2. I need to apply the negative through, so it would be a negative 7 plus x. And then this would be add a negative 8 or just subtract 8. And this will be a subtract x. All over x squared minus 9. And gather like terms. X, so x, that'd be 2x minus an x is just an x. 2 take away 7 is negative 5. Negative 5 minus 8 is negative 13. All over x squared minus 9. And that would be my final answer for that question. Hopefully that gave you enough examples that you can now go and try some questions in the textbook. Practice lots of those.